Hello everyone. In this video I'm going to review the basics of adding and subtracting radicals. We go by three main rules. They are, your radicals need to have the same index, otherwise known as the root, the same radicand, in other words, what's underneath the radical, or what's inside the radical, and then like coefficients. Coefficients, I'm referring to what's in front of the radical. So, for example, if I was given the expression square root of 2x plus 5 square root of 2x. The coefficients are the numbers in front of the radical. So in this case, the 1 that we assume is there, and the 5 in front of this radical. So coefficients, I'm referring to anything in front of the radicals, whether it be a number or a variable. Now we see with both of these, their square roots, so that means their index, or their indices, are the same. And their radicands, again, what's underneath the radical, the 2x and the 2x are the same as well. So we treat it just like adding two variables, or two numbers overall. So for example, if I said, what's 1 plus 5, you'd say it's 6. So in the same way, or a better example would be if I said, what is x or 1x plus 5x? And you tell me 6x. Not 6x squared or anything, but 6x. So in the same way, if I said, what's the square root of 2x plus 5 square root of 2x? We'd say it's 6 square root of 2x. The square root of 2x is treated just like an overall variable, just like with x plus 5x. I don't add what's inside the radicals, so in other words, I don't get 4x inside the radical. Square root of 2x stays the way it is, and all I'm combining is the 1 and the 5 on the outside. Another example would be something like 2x cube root of, let's say, 4y minus 6x cube root of 4y. Again, we identify that our index is the same for each radical. The radicand is the same for y. So all I'm concerned with is the coefficients, in this case the 2x and the 6x, subtracting them. So it's just like as if the radicals weren't there. It's as if I were saying, what is 2x minus 6x? That becomes negative 4x cube root of 4y. And that would be my answer. So with those three rules, something like this, square root of 3x plus the square root of 2x, I can't combine. I can't break them down any further, and they have different radicands. So automatically, I can't add them. Or if I said the cube root of 4y plus the cube root of 6, or let's just say I'll say 2 cube root of 4y, or hang on, I'll get this right. Let's say the fourth root of 4y is what I was going for. Again, we said we can't do anything with this because the indices, the 4 and the 3, the index, are different for each one. And finally, to that third rule with coefficients. Let's say I had 2x square root of 3 plus 4 square root of 3. In this case, my radicands are the same, my index is the same, both of them are 2, but I can't add 2x and 4 normally without the radicals, so they're not like terms. So in this case, I can't write it any simpler than what I have. If you want to get very technical, you could factor out a 2, but it's not going to make the question any simpler. So these are the way these three rules interact. I have to have the same index, radicand, and coefficients to add or subtract radicals.